All right, so we're going to sink our teeth into some harder derivatives. These ones are going to involve us mixing up both the chain rule and the product rule together to get a derivative. So at first glance, I'm seeing two different functions, f and g, being multiplied together as a product. So the product rule tells me I need to go get that derivative. So I'm going to write down on the side, as typical, what f is and what g is before I start. So f is the function x, the first thing. G is the square root of x squared plus 1, which I'm going to rewrite as x squared plus 1 all to the 1/2 power. Okay, so the derivative of f, which I'm going to need when I do product rule, derivative of x is just 1. The derivative of g is going to be more difficult because you're trying to take the derivative of something that's complex to the 1/2 power. So the way you do chain rule here is you drop this 1/2 down, you keep the bracket the same, you subtract 1 from the power and get negative 1/2, but then you multiply by the derivative of what's inside this bracket. The derivative of x squared plus 1 is 2x. Before I go plug that in, I might as well simplify it while I'm here writing it down. The 1/2 and the times 2 is going to cancel. The x is going to remain on top. And this is a negative exponent, so it's going to shove this downstairs. And it's a 1/2 power, so it's going to become a square root of x squared plus 1. This is what g prime is. The half canceled with the 2. The x is in the numerator. The negative exponent means x squared plus 1 shoves downstairs, and the 1/2 meant it was a square root. So I'm going to use f, g, f prime, and g prime into our product rule formula. So to get the derivative of capital F of x, you were doing f prime times g plus f times g prime. The derivative of the first times the second, derivative of the second times the first. So, inputting the numbers, f prime was 1. G is square root of x squared plus 1. F is x, and g is x over square root x squared plus 1. So if I simplify this a bit, you'll get square root of x squared plus 1. You multiply the x by the x and get x squared. And multiply the denominators together, and you just get square root x squared plus 1 in the bottom. I'm going to make this over 1 so you could maybe get a hint of what your next step should be. You're trying to add two fractions together, so I'm going to get a common denominator, which means the first bracket of x, or the first term of x squared plus 1, I'm going to multiply by the x squared plus 1 on top and bottom to therefore get a common denominator. I'll just leave this second term the way it was. So when you multiply the root by itself, the root cancels. You're left with x squared plus 1. In the bottom, you have the square root of x squared plus 1. The second term is just x squared over square root of x squared plus 1. Now you can add those up. You just combine the denominators together. To remind you, if you'd had 2 over 7 plus 3 over 7, you combine those together and write 2 plus 3, and you only write the 7 once, right? You get 5 over 7. So I'm going to follow that model and hammer these two together under the same denominator. So I'm going to get x squared plus 1 plus x squared all over the square root of x squared plus 1. You only write it the once. Same reason I did it here. X squared plus x squared makes 2x squared plus 1 over the square root of x squared plus 1. How do I know if I'm done at this point? If you don't see any common factors anywhere, I don't see any negative exponents, so I'm pretty happy leaving that answer just where it is and getting 2x squared plus 1 over the square root of x squared plus 1. What a fun question. Okay, so the second part, looking at a product again. This term is going to be f. That term is going to be g. So the f is 2x plus 1. G is 4x minus 1 all to the 5th power. So the derivative of f is going to be easy. Derivative of 2x is 2. Derivative of 1 is 0. The derivative of g prime, however, is going to require us to use chain rule. Drop the power down, 5. Keep the bracket the same. Subtract 1 from the power times the derivative of what's in that bracket, most often forgot big, times by 4. So I'll reorder that. 4 times 5, 20, bracket, 4x minus 1 to the 4th. This is my g prime. Here's f prime. Here's f. Here's g. To get this derivative of capital F, you do the product rule, which says derivative of the first times the second plus the first times the derivative of the second. Take the derivative of one thing times the other thing left alone, and then add them together. F prime is 2. G was 4x minus 1 to the 5th power. F is 2x plus 1. And g prime is 20 and 4x minus 1 to the 4th power. So there's now 2 terms here. This term and that term with 3 things in it. I actually see a common factor. I see 4x minus 1 here and 4x minus 1 there. And in fact, I see 4 of them in one and 5 in the other. So I can take 4x minus 1 to the 4th out of both terms. I also see a 2 in 20, and that 2 can come out as a common factor as well. And if I take both of those out, the 2 out, and a bunch of the 4x minus 1s out, taking the 2 out of the first term, it goes away, and 4x minus 1 to the 5th leaves 4x minus 1 to the 1, plus 2x plus 1 stays behind. The 10 has stayed behind, and the 4x minus 1 to the 4th is gone out front. So I have 2, 4x minus 1 to the 4th. I'm going to fart around with this inside bracket. 4x minus 1. Put the 10 on both terms. Plus 20x plus 10. Gather like terms in that square bracket. 24x plus 9. Question usually asked, Am I done yet? How do I know if I'm done? My answer is usually, well, do you see any negative exponents? The answer is no. Do I see any common factors? Yeah. This is 3 times 8, and this is 3 times 3. Looks like I can take a 3 out of there. I got to go one more step. So if you're going to take the 3 out and remove it, I'm going to take it out and move it all the way in with the other coefficient. And make that 2 times 3 is 6, bracket 4x minus 1 to the 4. And what's left behind is 8x plus 3. So, good news with the question is, if I move back to show the whole question here being done at once, remember, if you have written this line correct, everything correct there, so I'm seeing the fact that it's a chain rule written in there. You did 5 times 4. I'm seeing a chain rule there correct, f prime g plus fg prime. If you've got that level of work done, you're looking at like 2 out of 3 in the question. The rest of this simplification is fighting to make it look as pretty as possible, and it's the extra mark. Okay, once you have the first equation right, then you're showing me you've done the calculus, the chain rule, and product rule correct. The rest of it is showing me that you have the acumen of a strong calculus student. So I'll leave those 2 where it is, and I'll do another video that is going to do a couple of other questions after you have the opportunity to give them a try.